Hi, welcome back. Let's continue our conversation about sampling. So remember that in a simple random sample, each unit of the population has the same chance of being selected regardless of who else has already been selected. Now, simple random sampling is the simplest, but it can be expensive and difficult to carry out. And there are times when we want to look at more complicated sampling schemes. And we're not gonna talk a whole bunch about this, but we're gonna take a minute and look at these. So this is just a simple random sample. Every member of the population has an equal chance of being selected. This is analogous to pulling names out of the hat or selecting bingo balls or, that lottery ball machine, right? Sometimes we want to be a bit more systematic. And so systematic sampling is another form of sampling that can be random, actually is random, if you're careful. So what you do in systematic sampling is you list out every member of your population, and then you choose individuals at regular intervals. So think about our Gettysburg Address and our slide where we had all the letters, all the words listed out. And we knew we wanted 10 words, so maybe we just selected words 1, 21, 41, 61, selected every 20th word. That would have been a systematic random sample. We can also make what's called a stratified sample. So what we do is we divide our population into subpopulations, and then we draw random samples from each of those subpopulations. This mechanism is used primarily when we want to make sure we've got equal representation from each subpopulation. So an example here would be if we were carrying out maybe a clinical trial, we would pick a certain number of men and the same number of women if we wanted to make sure we had equal numbers of men and women in our study. But our selections from each of our subgroups are random. And lastly, we can use what's called a cluster sample. So we divide our population into subgroups that are approximately the same size, and then we randomly select those subgroups and include that entire subgroup. So, for example, suppose we're wanting to sample students at a university. Maybe we randomly select classes, and then we administer a survey to every student in those classes. That would be an example of a cluster sample. And then our data become the statistics of that cluster. All right, so the realities of sampling are that while a random sample is ideal, it's often not feasible and sometimes not possible for a lot of reasons. It could be we can't get a list of the entire population. Think about if you're trying to draw some inferences about adults in the United States. It's not likely we're going to have a list of every single adult in the United States that we can sample from, or that we can look at to organize from. You're not going to be able to contact every single adult, right? So that's why we can't sample everybody. Sometimes our population of interest needs to be altered to something more feasible. So maybe instead of every single adult, we can talk about just the adults in a single city and then generalize from that. That might work. In practice, we almost always have to think hard about potential. We always, not always, almost always have to really spend some time considering our potential sources of sampling bias. so that we can plan how to avoid them. Even if a truly random sample isn't available or isn't possible, we can still avoid sampling bias if we are careful and do our best to make a representative or random sample. There are, however, some bad methods of sampling that we really want to try to avoid. We don't want to select our sampling units that are based on something that is obviously related to the variables we're studying. For example, if we want to study if we want to look at how much students study, we don't want to just sample the students in the library, right? If we want to investigate how many people or what portion of the population have hired a personal trainer, we do not want to only sample people who read fitnessmagazine.com, right? In both of those cases, we are going to have a sample that we're going to be drawing our samples from a subgroup that is already more likely to be doing the thing we are interested in studying. We also don't want to just let our sample be comprised of volunteers, because people who choose to participate are probably not representative of the entire population. The same thing goes for emailing or mailing the entire population, because that is really a volunteer sample. That's not going to be a random sample, right? So for example, if an airline emails all of its customers asking them to rate their satisfaction with their recent travel, that's not going to be a random sample. Got to be careful there. So remember that we're trying to get a sample that represents our population. We know that sampling bias is something we want to be careful of. But there's another, so once we get our sample, then we're going to calculate some data. Well, we have our data. And there might be some other forms of bias that can crop up between our sample and our data. So a lot of times, especially when we're working with people, our data takes the form of answers to questions. And we got to be careful. And our other forms of bias to watch out for include question wording bias, context bias, and people give inaccurate responses. And there's a whole lot of other possibilities. So let's talk about question wording. One study asked, do you think the U.S. should allow public speeches against democracy? And the question was asked, do you think the U.S. should forbid public speeches against democracy? Same survey asked these two questions, and they're sort of the same thing, but check this out. 21% of respondents said that speeches should be allowed. In other words, 21% of respondents said that speeches against democracy, public speeches against democracy, should be allowed. 39%, however, said that speeches should not be forbidden. Those are two different numbers that really answer the same question in the same way. They both say that public speech should be allowed. Why is the second number higher? This is an example of wording bias. Forbid is much stronger language than allow, and people reacted more strongly to that, to the notion that public speeches against democracy would be forbidden, and they didn't like it. So be cautious of your question wording. Let's take a look at another example. A random sample was asked, should there be a tax cut, or should money be used to fund new government programs? 60% said we should have a tax cut. 40% said we should use the money to fund new programs. A different random sample was asked almost the same question. Should there be a tax cut, or should the money be spent on programs for education, the environment, healthcare, crime fighting, and military defense? This time, only 22% wanted the tax cut, and 78% wanted those programs. What's the difference? Well, we called out specific programs. We specified what programs we wanted. Now, no matter how you feel about this, the example, the point here is that your question wording matters. These two questions, again, we're getting at pretty much the same thing. The wording made a huge difference in the response. Let's talk about context. Ann Lander's column asked readers, if you had to do it over again, would you have children? Okay. When the request for data contained a letter from a young couple which listed the worries about parenting and the various reasons not to have kids, 30% said they would still have children. Now, Newsday conducted a random sample of all U.S. adults and asked them the same questions without any additional material. And 91% said that yes, they would have children. Context, whether it's particularly in the form of additional material that can be used to color people's frame of mind before they answer, matters. Let's talk about inaccurate responses. It's not that people lie, it's that people make mistakes and they don't always. They just don't think about everything. And people were inaccurate. So in a study on U.S. students, 93% of the sample said they were in the top half of the sample regarding driving skill. We think a lot of our own skill. We can't all 93 of us be in the top half, right? We can't have 93% of the people in the top 50%. That doesn't work. The math just doesn't work there. Another example, from a random sample of all U.S. college students, 22.7% reported using illicit drugs. What do we think? Is that accurate? Maybe. But people sometimes have a hard time admitting to doing something that they think others won't react well to or respond well to. So we tend as people, it's a very human thing, to highlight the positives or the things that we think other people are going to perceive as the positives. And we tend to downplay or underestimate the negatives or the things that we are worried about other people perceiving as negatives. Just something to be aware of. So in summary, we need to always think critically about how the data were collected and recognize that not all forms of data collection lead to valid conclusions about the population. And the easiest way, if you take nothing else away from this class, remember this, and you will instantly be a more informed, critically aware consumer of statistical information. All right, that's it for this section. We'll come back in the next video and talk about section 1.3, in which we talk about experiments and observational studies. I'll talk to you again soon.